deadbeat controller. It is a digital controller. This is the first experiment, part A. Before study about the deadbeat controller, we should understand what is digital controller. So far, we have seen continuous controller. The controller output will be continuous signal like this. This is varies from 4 to 20 milliamps. So a continuous signal. But in the case of digital signal, first thing is it will be discretized like this. Suppose this is first sampling period, second sampling period, third sampling period. Like that, you will get the same thing you will get like this. Digital controller output will be every sampling instant only you will get controller output. So by using the digital signal, you cannot open the valve. For example, if you consider a digital control system, you will have a digital controller, D of Z. So it is in Z domain, Z domain. It is in Z domain. Continuous we study in S domain. The frequency domain for continuous is S domain. For Z domain, for discrete signals. So here, your process is continuous. You cannot convert the process into digital. Process always continuous only. If it is a level process or flow process or whatever may be the process is continuous only. You cannot discretize. Before that, you are having a valve or something that you cannot convert into digital one. This is the valve. Before that, you will have I to P. So before that, you need a continuous signal. So we have to convert this into this discrete signal into continuous one. For that, you will have a circuit called hold circuit. Before giving to the hold circuit, it should be given to DAC, digital to analog converter. Digital to analog converter, if you can give this digital signals, it will again give the analog value of discrete signals. Digital will be converted into discrete, but these values will be available periodically, not continuous. To convert this into continuous signal, you need a hold circuit. This is called hold circuit. What the hold circuit will do, suppose this is the digital signal. This is the controller output available like this, continuous. So DAC will convert into voltage like this. A number is converted into voltage like this. This is output of DAC. Again, it is discrete signal. Now, digital is converted into discrete signal. Convert this into analog. You have to hold this value up to this next sample. You have to hold this signal up to next sample. You have to hold this signal up to next sample. So now you got a continuous signal. Now you got a continuous signal like this. So the hold signal will hold the previous value to next sampling period. So set point star of K is required. Here PV of K is required. Here you will get E of K, you will get. If you give E of K as input to that digital controller, you will get digital output that will be converted into discrete signal by DAC. Then a hold circuit will be there that will hold the digital circuit. This is the arrangement. So how to design a digital controller? If you have a digital controller, you can put here and you can control this process. So to get a digital controller, generalized digital controller expression we have to get. For that, we should understand one thing here. Suppose I'm having G1 of S and G2 of S here. G2 of S. If you can multiply these two. In Laplace domain, you can multiply these two. That already we have seen. That's why you'll write G1, G2 of S like that we'll write. Suppose I'm having G1 of Z I am having and G2 of Z I am having. In Z domain, I am having the transfer function. You cannot multiply these two together. You cannot multiply these two together. If you want to multiply these two together, in between there must be a sampler. G1 of Z and G2 of Z can be multiplied. These and all we'll study in detail in the theory class. Here for laboratory purpose, in between some sampler is there, then only you can multiply. Otherwise, you cannot multiply these two. So if you consider this transfer function, this is here we have a hold circuit. That's why a sampler is there. Set point is given here. Here set point of K is available. So discretized. That's why it can be given to D of Z. The output of this D of Z is given to sample and hold circuit along with a DAC. DAC and sample and zero order hold circuit is given here. It consists of DAC as well as hold circuit. After that, your process is there. Your process is there. You can draw a sampler, then you can give here. Now, the transfer function of this zero order hold is 1 minus S power e power minus Ts upon S, where T is the sampling period. The transfer function of this zero order hold is 1 minus e power minus Ts upon S. This is H hold circuit transfer function. This is process transfer function. These two are in S domain. There is no sampler between them. That's why these two can be multiplied. But before that, one sampler is there. That's why we can write forward path transfer function can be written as D of Z multiplied by Z transform of H of S, that is hold circuit, and G of S. You can multiply in S domain only, not in Z domain. That's why after multiplication, you have to convert this into Z transform. Therefore, forward path transfer function is D of Z, HGP of Z you can find. After multiplying H and G, you can find Z transform. Therefore, this way only you can multiply. But if you write this is not equal to D of Z, H of Z, G of Z. This is not equal to G of Z, H of Z, G of Z. This is wrong. There is no sampler between the zero order hold and process. That's why we have to multiply these two in S domain. Then we have to find the transfer function. That's why this you will get D of Z, H of Z. This is a forward path transfer function. What is the loop transfer function? Loop transfer function is 1 plus loop transfer function. If you want to write the transfer function for this closed loop, what is the loop transfer function? Here 1, the feedback is 1. Therefore, again, D of Z, HGP of Z, HG of Z, HG of Z. This, since it is process, instead of calling G, we can call it as GP. HGP of Z, we can call. This is the closed loop transfer function for digital control system. What is the input? Input is, what is the output? Output is Y of Z, discrete domain. What is the input? Set point of Z, Y set point of Z. This is the input. This is the output. This is the transfer function. From this, we can write Y of Z upon y set point of z. Instead of telling set point of z, I am telling y set point of z. It is set point for y. That's why I can call it as y suffix set point of z. That is equal to, here, this is set point, y set point of z. Here, you can call it as set point of z or y set point of z. Here, the output is y of z. Therefore, the transfer function is y of z upon y set point of z equal to d of z hgp of z upon 1 plus d of z hgp of z. This is the transfer function. From this, we can find the d of z. That is the general expression for controller. Cross multiply, what you will get is 1 plus d of z hgp of z hgp of z multiplied by y of z upon y set point of z equal to d of z hgp of z hgp of z. You can write this as y of z upon y set point of z equal to this, and this is multiplied, equal to d of z hgp of z. If you bring this to the right hand side, minus d of z hgp of z and y of z upon y set point of z. That's why we got hgp of z in both cases. That's why that is taken outside. D of z in both cases, that's why taken outside. The remaining thing is here 1, here 1, here only y of z by hgp of z. Sorry. D of z equal to 1 by hgp of z, 1 by hgp of z multiplied by y of z upon y set point of z whole divided by 1 minus y of z upon y set point of z. This is the expression for d of z. This is the expression for d of z. Whatever may be the digital controller, this is the expression. What is hgp of z? What is hgp of z? To find a digital controller, you need two things. One is hgp of z, another one is y of z by set point of z. Y of z by set point of z. So, what is hgp of z? hgp of z is product of zero order hold and process. You have to find hgp of z first to find a digital controller. Next thing is you have to find y of z by y set point of z. It is nothing but a transfer function for the response. What is the input? Y set point of z. What is output? Y of z. Therefore, if you find y of z by y set point of z, it is nothing but a transfer function for response of the system. Response of the system. If you know the response, and hgp of z, you can find the digital controller.